Welcome to the Deep Dive. Today, we're taking a look at something really fascinating in medical AI. It's called Agent Hospital.
Right, and it's not just, typical software. Imagine a whole simulated hospital.
Yeah, with AI playing all the parts, the patients, the nurses, even the doctors. It's wild.
Exactly. And what we're digging into is how this virtual world helps these AI doctors learn how they actually sort of evolve their medical skills.
And it seems like it might be a kind of shortcut, a way to speed up getting better at medicine, but for AI.
That's the potential, yeah. Because these AI docs trained purely in this simulation, they've shown some, frankly, surprising results on real medical tests.
Outperforming other AI methods even.
In some cases, yes, on things like medical exam questions.
Okay, so our mission today is to unpack that. How does this simulated hospital work? How do the AIs learn? And, crucially, why does this virtual training seem to translate so well to the real world?
And the core tech behind it all, as I understand it, involves large language models, LLMs, but used in a different way.
Not just for text, right? Like, they're the brains for these agents.
Precisely. They power these autonomous agents moving around and interacting within this virtual hospital.
Oh, let's talk about building this hospital. The simulacrum construction, they call it.
Right. It's quite detailed. Think different zones, triage, registration, consultation rooms, exam rooms, a pharmacy, all the usual places.
Like a digital twin of a hospital layout, almost.
Pretty much. And then you have the agents themselves, two main types.
Okay, who are they?
You've got patient agents and medical professional agents, so doctors and nurses, and they have specific profiles.
Profiles, like background info.
Exactly. For instance, the paper mentions Kenneth Morgan, 55-year-old patient agent with hypertension, and maybe Robert Thompson, a 46-year-old AI dermatologist, good at skin surgeries.
So they have specialties and histories.
Yeah.
That must make the simulation more realistic.
It does. And the whole process runs on these 8 main event types that mirror a real hospital visit.
Okay, walk us through that. How does it flow?
Well, it starts with disease onset. So Kenneth Morgan develops a skin problem. Then triage, maybe an AI nurse, Catherine Lee, directs him to dermatology.
Got it. Then registration, I assume.
Yep, registration with another nurse agent, Alexander Davis's, followed by the consultation with our AI dermatologist, Robert Thompson.
And after the consult.
Then comes medical examination. Maybe nurse Jessica Chen handles getting results. That leads to the diagnosis from the doctor.
Right.
Then medicine dispensary via maybe nurse Andrew Jackson. And finally, convalescence, the recovery phase.
That covers the whole patient journey. Anything else?
There's also an event called reading books, specifically for the doctor agents.
Ah, so they're continuously learning, even within the simulation.
Exactly. It models ongoing professional development. And a huge advantage here compared to the real world is getting feedback.
Feedback on treatments. How?
Well, in the simulation, you can instantly see if a treatment worked for the virtual patient. It creates this really tight, closed learning loop, much faster than waiting for real-world patient outcomes.
Okay, that makes sense. So you have the hospital, the agents, the process. How do the AI doctors specifically get better? This is the agent evolution part.
Yes, precisely. It falls under this umbrella called Simulacrum-based Evolutionary Agent Learning, SEAL, for short.
Okay.
SEAL covers building the simulation, which we talked about, and then this agent evolution piece. And the method they use for the doctors is called MedAgent Zero.
MedAgent Zero. Why zero?
The zero is key. It means it learns without needing any manually labeled medical data. None.
Whoa, okay, that sounds like a big deal. No need for humans to pre-label thousands of cases.
Exactly. It uses synthetic data generated inside Agent Hospital.
How does it generate that data? Starting with patients.
Right. It starts with patient agent generation. Basically, they use an LLM combined with medical knowledge bases.
Like textbooks and medical databases.
Kind of, yeah. This combo automatically creates diverse virtual patients with basic info, medical history. Like, remember Kenneth Morgan? Maybe his history notes childhood chickenpox, which makes him more likely to get herpes zoster later.
Ah, I see. So the history influences the simulated diseases.
Yes. And it generates symptoms, even simulated lab reports. Plus, there's a quality control agent making sure it all lines up with actual medical knowledge.
That's pretty sophisticated patient creation. So the AI doctors then interact with these generated patients, using our example.
Let's take Dr. Thompson, the dermatologist, and Kenneth Morgan's case. Dr. Thompson sees the virtual symptoms blisters, pain, maybe a rash, gets the simulated lab results showing VZV antibodies.
Which points towards herpes zoster or shingles.
Exactly. So the AI doctor has to decide. More tests, diagnosis, treatment plan. And here's where it gets really interesting. The doctor agents have internal resources,
Resources, like what?
a medical case base and an experience base.
Okay, what's the difference?
Think of the medical case base, like a library of past successful cases. Patient X had these symptoms, you did Y, they got better, storing what worked.
Got it. And the experience base.
That's more like learned rules or heuristics, almost like intuition. Things like, if you see these symptoms in an older patient, consider herpes zoster more strongly because age is a risk factor. It captures lessons learned, especially from mistakes.
So one stores successes, the other stores lessons learned, often from failures.
You got it. The case base grows with every successful treatment. The experience base evolves when things go wrong. The AI reflects, tries to figure out a rule to avoid that mistake again.
And if that rule works in later simulations.
Then it gets validated and added to the experience base. It's this constant cycle of practice, feedback, reflection, and updating its own knowledge.
Like building its own medical knowledge base from scratch through virtual experience. Okay, the million-dollar question. Does this virtual learning actually help in the real world? Let's talk about scaling and application.
Right, this is where the evaluation comes in. They tested these evolved doctor agents within Agent Hospital on, well, a lot of stuff.
Like what kind of tasks?
Things like choosing the right medical tests, making diagnoses, recommending treatments. And they did this across 32 different medical departments, covering about 339 diseases. So pretty comprehensive.
Okay, and what did they find? Did the practice pay off?
Very much so. There was a clear pattern. The more virtual patients an AI doctor treated, the better its diagnostic accuracy became.
So experience really counted, even simulated experience.
Absolutely. They showed a chart, for instance, for respiratory diseases. Accuracy climbed steadily as the AI handled up to, I think, 50,000 virtual patients.
50,000, wow. That's a massive amount of practice, way more than a human could get in the same time frame.
Exactly. And this wasn't just in one area. The improvements were seen across many departments.
Could you use some examples?
Sure. Like rheumatic heart disease and cardiology started super low, like 9% accuracy. After the evolution process, it jumped to 82%.
9 to 82%. That's huge.
Yeah, really significant gains. Similar stories for things like memory hyperplasia, influenza B across the board. The evolution process made a big difference.
Incredible improvements within the simulation, but does it transfer? The alignment between virtual and real worlds bit.
The crucial question, and the early results look positive. They checked if skills learned in Agent Hospital helped with real-world type problems.
How did they test that?
They used the MedQA dataset. It's full of questions styled like the U.S. medical licensing exams, the USMLE.
Okay, so real medical questions.
Right. And they found that as the AI doctors got better at diagnosing in the simulation, their scores on these real-world MedQA questions also went up.
Ah, so there's a correlation. Better virtual performance leads to better real-world test performance.
Exactly. It suggests the learning isn't just specific to the simulation, it's creating genuine medical knowledge that can be applied elsewhere.
That's a really strong sign.
And get this, these MedAgent Zero doctors actually outperformed some existing top AI methods on MedQA.
Wait, even methods trained on actual real-world medical data?
Yes. And MedAgent Zero did this without being trained on the MedQA data itself. It learned everything inside Agent Hospital.
Okay, that's seriously impressive. Learning purely from simulation and then beating systems trained on real data. This learning from success and failure must be key.
It really seems to be. Successes build that case base, the library of what works, but failures drive the experience base.
The reflection part you mentioned.
Right. An AI makes a mistake, it reflects, tries to generate a rule, don't make that mistake again, tests the rule, and if it helps, adds it to its experience base.
So it's constantly refining its don't-do list as much as its do-this list.
Pretty much. And the paper shows data on this, how these validated experiences and error rules build up over time in different departments, like respiratory.
Does it learn some things faster than others?
It seems so. The data suggests that experience accumulates faster for, say, choosing the right exams compared to making the final diagnosis.
Which makes sense. Diagnosis is often more complex, more variables.
Exactly. But the overall trend shown in areas like cardiology and nephrology was clear. More virtual patients led to better precision in both examination and diagnosis. Steady improvement.
This whole approach,
Yeah.
it feels like it could change a lot, not just AI, but maybe medical training too.
Absolutely. The researchers point that out. AI patients could be amazing tools for modeling diseases, training human doctors safely, protecting privacy,
And the AI doctors themselves.
faster learning, potentially reducing human doctor workload, maybe even helping make good medical advice more accessible, more equitable.
It's like an AI medical school on fast forward. And you mentioned parallels drawn to AlphaGo Zero.
Yeah, and Smallville, that AI social simulation, Agent Hospital kind of combines those ideas, self-learning like AlphaGo, but in a complex simulated social environment like Smallville, focused on medicine.
So the core innovation is using LLMs plus knowledge bases to create the training data within the simulation itself.
That's the heart of the SEAL paradigm, yeah.
Yeah.
Self-generating data in a realistic simulation drives the learning. And they have ideas for the future, too.
Like,
Improving the base AI models, getting the AI to generate more detailed treatment plans, maybe even having virtual doctors consult each other across departments.
okay, so wrapping this up, this deep dive into Agent Hospital shows, well, a really novel way to push medical AI forward.
Definitely. Simulating the whole hospital complexity lets these AI agents learn by doing, by experiencing, in a safe, controlled way.
And the result is AI doctors with surprisingly deep medical knowledge, skills that seem to actually apply to real medical problems.
Yeah, the fact they can learn purely from synthetic data and then perform so well on real benchmarks, even beating other methods, that's pretty significant. It points to a really promising path for AI in healthcare.
It really makes you wonder, doesn't it? Could virtual hospitals like this become standard tools, not just for developing AI, but maybe for training human doctors too?
It's a fascinating thought. Accelerating progress, developing new AI diagnostics, new treatments.
Could this fundamentally change how we approach healthcare, how we think about our own health? Something to definitely keep an eye on. Thanks for joining us for this deep dive.